derivative of x to the fourth plus y to the fourth equals 16 and express the answer in terms of x and y only. So I'm only going to be focusing on the second derivative portion by the way. So we have the standard function x to the fourth plus y to the fourth equals the value of 16. So here we must do implicit differentiation by taking the derivative of x to the fourth, which is going to be 4x cubed. Then I'm going to get plus, now I'm going to get y to the fourth, which is going to be the chain rule. You only do the chain rule with y. So I'm going to get 4y cubed, but then I'm going to get y prime because like, by itself, the inside function is automatically y prime when you're dealing with y. So that's that. Now you're going to get 0. So here, this will then be subtracted. So I'm going to get 4y cubed, then y prime equals 2. So this will then become negative 4x cubed. And then I'm going to be dividing by y prime. So now I'm going to be dividing by, actually not really y prime, 4y cubed. So that's this can cancel out. Then I'm going to get 4y cubed. So the answer for the actual derivative, so this is the first derivative. So it's going to be y prime. It's going to be, well, negative 4x cubed over the value for 4y cubed. So now this will then be these values, these 4s, they will then cancel out. And then now I'm just given negative x cubed over the value of y cubed. So that's the first derivative. But the question, like I said, it is asking for the second derivative. So from this portion, we need to know what the second derivative is in the first place. So that means we must solve for the second derivative. So what the second derivative is often expressed as y double prime. So y double prime. Seeing that we have like two different functions multiplied together, I consider this function, let's say f of x, and then I consider this function as g of x, let's say. Then that means here I must do the quotient rule. So that means here it's going to be the first derivative, so I'm going to do negative 3x squared. But then I'm also going to get y cubed. This is the original function, y cubed, for g of x. Then this will then be subtracted by negative x cubed, but then this will then be multiplied by the next function's derivative. So that means here it's going to be 3y squared, but then I have to do the chain rule again, especially, which is then going to be y prime divided by the value for y cubed, and then that will then be squared. So y double prime is then going to be, so I'm still am going to get like negative 3x squared. Then I'm going to get y cubed plus the value for 3y. Actually, I'm going to do like, still am going to like subtract. Actually, never mind. Let's just add. plus the value for 3x cubed y squared, then y prime divided by y to the 6, because 3 by 2 makes 6. And guess what? Like what y prime originally was, negative x cubed over y cubed. That was the original value of y prime, which was negative x cubed over y cubed. That was the original function here. So that means from there, we must continue evaluating y double prime in this fashion. So negative 3x squared y cubed plus the value for 3x cubed y squared. Then you plug the function in. So that was a negative x cubed over y cubed in this way. So this will then be divided by y to the 6. So now this will then become simplified. Okay, so I've already like done that portion. I just like combined like terms and I simplified the least common denominator, and now I'm gonna simplify the rest. So this means here the top portion will still stay the same. So that means here I'm gonna get 3 plus 6, which is 9. So y to the 9. Then I'm gonna get the value for negative 3x squared y to the 6 minus the value for 3x to the 6. Then I'm gonna get y squared. So I think that's y double prime for now. So therefore, in terms of simplification, so y double prime was equal to this function. So y double prime was equal to, so negative 3x, so negative 3x squared y to the 6 minus the value of 3x to the 6, then y squared, all divided by y to the 9. I think that's it. The question here is, then you have to plus the answer for x and y only. Well, I think that's it.